In this short presentation, we'll look at the new capabilities in NX 2312 for manufacturing, released in December 2023. We added new functionality to our part manufacturing solutions, including CAM, Additive Manufacturing, on-machine probing, CMM Inspection Programming, and part manufacturing data management. We'll also discuss the new capabilities in NX's Assembly Planner and Line Designer. First, let's look at the enhancements in NX CAM, one of the most comprehensive solutions for NC programming on the market today. A new roughing operation, called Quick Roughing, is now available. The operation is recommended for programming and machining of simpler prismatic parts, mold cavity and cores, dies, casting, and forging with contoured shapes using planar cut levels. The operation requires part body and blank input. The operation generation is fully multi-threaded. It has a very robust holder collision avoidance where it maintains the specified clearance values accurately. The cut pattern is automatically defined based on the geometry region. For fully open or closed regions, it is using follow periphery, and for semi-open regions, it uses follow part. To limit machining regions, trim boundaries can be specified. Corner smoothing is also available, which helps reduce tool embedding in sharp areas of toolpath.
Quick roughing is a new 3-axis operation subtype that efficiently removes large volumes of material in planar levels with reliable tool and holder collision and gouge detection. It is recommended for quick programming and machining of simple prismatic parts, mold cavities, cores, dies, castings, and forgings with contoured shapes. Quick roughing is simpler to use and generates tool paths faster than cavity milling. It provides efficient and safe removal of blank material, yielding a reliable stock model for subsequent rest roughing operations. We'll begin by creating a new operation and generating the tool path. Range type can be determined automatically or it can be user specified. The default is automatic. Automatic detects the top and bottom of the part and uses the volume as the machining range. If the blank extends above the part, you can reposition the top plane using the Specify option. The cut range can be specified by keying in values, graphically dragging the arrow, or selecting faces. Cut levels mode may be determined by constant depth or by number of levels. Top-off flat faces is on by default. Flat faces that are less than the specified minimum width are not topped off. This prevents the unnecessary cutting of narrow steps. The minimum top-off width can be expressed as a constant value or as a percentage of the tool diameter. Corner smoothing prevents an abrupt change in tool direction and allows you to maintain higher feed rates and tool stability. There are 3 smoothing options. None does not smooth corners for any cutting pass. All passes smooths corners for every cutting pass. All but last pass smooths all corners except for the cutting passes closest to the part. Quick roughing uses a single hybrid cut pattern which is a combination of follow periphery and follow part. This behavior can be illustrated by 3 use cases, each with a different type of cut region. Use case number 1 occurs when cut regions are open on all sides with no walls. This case uses the follow periphery pattern, cutting from the outside in. Use case number 2 occurs when cutting semi-open pockets. The tool plunges outside the stock and offsets are open. This case uses the follow part pattern, cutting from the outside in. Use case number 3 occurs when cutting closed regions. The tool ramps inside the pockets with closed offsets and uses the follow periphery pattern, cutting from the inside out. Small area avoidance prevents toolpaths from being generated in closed regions that are smaller than the specified region size. In this example, the cut region is larger than the specified region size of 50% tool diameter, so the region is cut. If the cut region is smaller than the specified region size value, then the region is not cut. The minimum ramp length must be less than or equal to the specified region size. Otherwise, the region size value will be changed internally to the specified minimum ramp length. Click No to continue generating the toolpath and internally change the region size value. Click Yes to cancel the toolpath generation.
Face mill. Zigzag is a new operation which provides a simplified and interactive way of programming face milling toolpaths. You can interactively specify parameters like cut angle, runoff, blank thickness, and pattern offset directly in the graphics area. It offers automatic toolpath preview and fast generation performance.
The new Face Mill Zig Zag operation makes programming simpler through a new interactive graphic user interface that allows you to specify parameters like cut angle, runoff, blank thickness, and pattern offset. We'll begin by creating a new operation. Face Mill Zig Zag is new. Specify the cut area and generate. You can edit the toolpath by dragging graphics. The preview updates dynamically. Face Mill Zig Zag is blank sensitive, meaning the operation will only generate the toolpath within the blank volume above the specified cut area. Notice containment is set to blank geometry. Face Mill Zig Zag is also IPW aware. It uses the stock updated from the previous operation. Notice the blank containment is set to 3D IPW. Pattern offset and a tool runoff can be defined by dragging graphics.
A new wall finish barrel swarf operation subtype allows you to swarf deep planar or contoured walls using a 5-axis tool motion with tangent barrel, taper barrel, and standard barrel tools, using either zig, zigzag, and continuous spiral cut patterns. The purpose of this operation is to generate 5-axis barrel milling toolpaths for machining of steep surfaces or walls. Due to the large barrel radius of the tools, the resulting toolpath is significantly shorter because of the larger stepovers you can apply, and the final surface finish is superior as compared to when using ball tools. The operation is easy to program with minimum required inputs of surfaces and curves to generate the toolpath. Avoidance and tilting is automatic based on specified part and fixture geometry. Users can interactively adjust the cutter contact area for the target machining surface. Toolpath can be further optimized to cut portions of the surfaces by regions or lanes.
A new wall finish barrel swarf operation subtype allows you to swarf deep planar and contoured walls using a 5-axis tool motion with tangent barrel, taper barrel, and standard barrel tools. Wall finish barrel swarf supports zig, zigzag, and spiral cut patterns. Some common use cases include automotive and general machinery parts. The general workflow consists of selecting the walls, specifying the upper and/or lower curves to determine the direction of the tool axis relative to the walls, defining the pattern based on the selected upper or lower curve or morphing between them, and defining the tilt and avoidance options. We'll begin by creating a new operation. Wall finish barrel swarf is new. Select the wall or walls you wish to cut. Multiple walls must be contiguous. Select upper and/or lower curves to determine the tool axis orientation relative to the selected walls. You must be sure to specify the correct curve as upper or lower relative to the wall to orient the tool correctly. For example, if you wish to orient the tool with the flute pointing down, you need to select an upper curve on or near the top edge of the wall. The same concept applies when selecting lower curves. Select the top edges of the walls to specify the upper curve. Multiple curves must be contiguous. The zig cuts run parallel to the selected curves. In some complex parts, such as transmission housings or gearbox casings, the upper and lower curves cannot be used as pattern curves due to their free-form shapes. In these cases, the option Offset from Guide allows you to specify a pattern curve explicitly. Specifying an upper and lower curve allows you to morph the cut pattern between the top and bottom of the wall. The edge along the bottom of the wall has been selected as the lower curve. The edge along the top of the wall has been selected as the upper curve. The tool path morphs between the upper and lower curves. Options are available under Axis and Avoidance that produce a collision-free tool path by tilting the tool automatically. Lead angle defines a range between the specified minimum and maximum values within which the tool lead may occur. The tool lead adheres whenever possible to the specified minimum value, deviating from that value to avoid collisions only up to the specified preferred angle. The preferred lead angle must be greater than the specified minimum and less than the specified maximum angle. Contact height options determine the portion of the barrel that is permitted to contact the part. The new Show Contact Preview toggle shows the minimum, maximum, and preferred contact rings on the tool. Contact points help you visualize the locations of the wall where the tool contacts the part at any given point along the tool path. The bottom of the barrel is denoted by a value of 0, and the top of the flute is denoted by a value of 1. The preferred contact height determines the contact point of the tool referenced on the barrel radius. The preferred contact height must be greater than the specified minimum value and less than the specified maximum value. The system will hold to the preferred contact height whenever possible. The minimum contact height determines the allowable contact point deviation below the preferred point. This value must be between 0 and 1 and be less than the maximum and the preferred contact height. The maximum contact height determines the allowable point deviation above the preferred point. This point must be between 0 and 1 and be greater than the minimum and the preferred contact height. Avoidance and axis smoothing provides options that allow you to create collision-free tool paths by tilting and/or retracting, and is particularly useful in cases where the walls form sharp internal corners. Here we have an operation that cuts inside a closed area and morphs between the top and bottom curves while using a zigzag cut pattern. Retract cuts as much of the wall as possible without colliding with the adjacent wall by retracting from the corner. Tilt-retract cuts as much of the wall as possible by tilting away as it approaches the adjacent wall and then retracting. In some cases, this option can safely remove more material from the corner than retracting alone. None does not avoid collisions. Report collisions generates a collision report in the information window.
Based on user feedback, we have enhanced holemaking with two new very cool features. Use initial control point and bottom clearance for threading operations. In past releases, when drilling or pilot drilling to a depth less than the IPW stock of a face, users were unable to define a control point or start position for subsequent operations. Users' expectations is that the next drilling operation, usually deep hole or gun drilling, will rapid to the same clearance value above the IPW. This enhancement introduces a new control point option called Use Initial, which will allow subsequent operations to use the initial control point. This will effectively allow all subsequent operations better control for entry into the previously drilled hole, reducing tool wear, tool breakage, and improving quality. Users have also requested the option to allow a bottom clearance to reduce the depth a tap or thread mill goes down a thread feature. While this is not using the thread feature information for the threading operation, it is commonly known, for several reasons, that it can be necessary for the tool to stop short of the specified depth. For holes and bosses that do not have a thread data, non-NX parts, this enhancement has also been requested. This will enable users to have full control of how far the threading tool stops from the bottom of the feature.
The control point used by the initial drilling operation can now be used by subsequent operations in the sequence, allowing the tool to move to the same clearance position above the IPW for each operation and preventing a rapid movement into the previously drilled hole. As a result, you can achieve better control for entry into the hole, improve machining quality, and reduce tool wear. In this example, we have operations that pre-drill and drill a hole. The first is a pilot drilling operation. Notice that the IPW extends above the part. The rapid move stops safely above the IPW at the specified control point, drills to the depth of the pilot hole, and then retracts. The next operation is a deep drilling operation that uses a machine feature control point. If we set the in-process workpiece to use 3D, generate, and display IPW, we can see the tool rapids from the clearance plane into the pilot hole before drilling, which is not desirable. The new control point option, Use Initial, prevents the rapid movement into the pilot hole by using the control point specified in the initial operation. When we regenerate the tool path, display the IPW, and play, we can see the tool no longer rapids into the pilot hole. Instead, the tool rapids to the control point above the IPW, followed by a feed rate motion into the pilot hole to the start position, drills, and retracts. Use Initial may be used for all subsequent operations. Again, we can select Use Initial to specify the control point used in the first operation. When we select Play, we can see the tool rapids to the control point safely above the IPW, feeds into the hole to the start position, drills, and retracts. This enhancement provides a bottom clearance option for threading operations that allows you to determine how far threading tools stop from the bottom of the feature. In this example, we have hole features of equal depth. Here, we can see several holes are threaded, each with their own thread depth. Predefined thread length is an existing option that allows you to define the depth of the thread measured from the top of the hole feature. The bottom clearance option is new. This value is measured from the bottom of the hole feature. If we type in a value of 6, we can see the thread depth of the last 4 holes have been reduced by 6 mm, offset from the bottom of the hole feature. The other thread depths are too shallow to be affected by the 6 mm bottom clearance. A bottom clearance value of 15 affects more of the thread depths. If we generate the tool path and click play, we can see the threads in the affected holes cut to the full thread depth, less the bottom clearance value. Bottom clearance works in exactly the same way for thread milling operations. If we generate the tool path and click play, we can see the threads in the affected holes cut to the full thread depth, less the bottom clearance value.
A new module, Tool Assembly, and other enhancements have been added to the Cloud Connect Tool Manager, which was released in NX 2306. Dynamic Assembly Tool Preview and Dimensions enable users to define and edit an assembly tool easier. Several search functions are also supported in this module. Multiple shanks are also implemented. Users can extract step data from 3D.stp file.
The Cloud Connect Tool Manager now contains a new user-friendly tool assembly module that graphically manages the assembly tool library and provides 3D shank extraction. We'll begin by creating a new milling tool with a shank. Specify the general and cutter parameters. The tool profile picture updates dynamically as you enter the cutter parameters. Click Shank and extract 3D data. The shank for the specified cutter is now created and displayed in green. Next, we'll convert assembly data saved in the tool data library to the assembly data library. A one-click conversion function has been implemented to quickly and automatically execute the conversion to the assembly tool library. The new tool assembly module is used to manage tool assembly data. The usual options are available with which to manage and filter the tool assemblies. The tool assembly module can be displayed in the card or list with summary mode. Now we'll create a new assembly tool. We'll create the assembly by specifying the tool and the holder. Each is a subtask in the tool assembly creation process. We'll begin by searching for the tool we created. The tool displays to the right. The tool subtask is marked as finished. Next, we'll specify the holder. The tool and holder assembly are shown. The holder subtask is marked as finished. The assembly preview changes dynamically. A single click converts the tool with holder to the assembly tool library. Notice that the new tool assembly has been created and added to the Cloud Tool Manager. To use the assembly in NX, select the tool picture and click Send Tool to NX in the ribbon. The tool assembly is displayed with the part.
A new workpiece called Mill Turn Workpiece have been added. This is making it simpler to create mill turn setups, as both milling and turning geometry is defined in this single geometry object. The Mill Turn Workpiece object is available in milling and turning type templates, and only when a machine tool is loaded. It combines the milling workpiece and the turning workpiece definition in a single geometry object, and should be used in setups where you do turning and milling operations, or turning operations only.
This new feature provides a more intuitive and faster creation of advanced CAM mill turn setups. The mill turn workpiece geometry subtype is new. This subtype is available in several milling and turning geometry templates and is available only when a machine tool is loaded. The dialog now uses the common Explorer style. The spun outline is now created automatically when part and blank geometry are defined. To assign the part and workpiece geometry, specify the available machine setup component of the loaded machine tool. The new mill turn setup structure is created.
Users can now leave feedback directly from within NXCAM. There are 3 levels of detail that a users can leave. The first level is to simply click Send a Smile or Send a Frown, indicating satisfaction or dissatisfaction with NXCAM, and the click Submit. The second level is to add a brief description telling us what you like or dislike about NXCAM. Both of these levels of feedback are anonymous and will be identified only by the customer's Sold To ID. There's a privacy statement you can access via the web browser and read through. The third feedback level is to take a survey. This survey is specific to NXCAM and allows you to provide detailed information that will be forwarded to the appropriate product owner for review.
You can now provide user feedback directly from within NXCAM by clicking one of 2 buttons in the NX title bar. There are 3 levels of feedback. The first level is to simply click Send a Smile or Send a Frown in the NXCAM title bar, indicating satisfaction or dissatisfaction with NXCAM, and submit. The second level is to add a brief description, telling us what you like or dislike about NXCAM. Both of these levels of feedback are anonymous and will be identified only by the customer's Sold To ID. There's a privacy statement you can access via the web browser and read through. The third feedback level is to take a survey. Clicking Survey gives you access to the survey form in the integrated web browser. This survey is specific to NXCAM and allows you to provide detailed information that will be forwarded to the appropriate product owner for review. Indicate the satisfaction level for the general areas that apply. You may also explain the reasons for your ratings by filling in the text field in the form. Click Next. Indicate your satisfaction level for the specific areas of NX that apply and type any additional comments. Fill in your email address, name, and company. This will allow us to follow up if necessary. You may continue interacting with NX while filling out the survey, allowing you to reference the functionality and user interface for your comments. When finished, click Submit.
Now let's look at the enhancements in multi-axis and fixed-plane NX additive manufacturing. Different additive technologies prefer different strategies for depositing material. In the case of WAM and ring-shaped parts, back and forth, short zigzag motions are preferred to using round and round racetrack motions. This operation automatically finds a drive curve and creates output across the drive curve. Since the stepovers vary, especially in the larger and shorter radius or around corners, it tries to accomplish this within a min and max bead size. If this is not possible, the area can be split into multiple regions, such that the min and max stepover can be honored.
Welcome to NX 2312 and multi-axis additive. In this video, we're going to take a look at the new functionality, Morph Across. Previously, we've had morph along. With morph along, you pick two drive curves and it morphs between the two drive curves. So if we look at the part on the right, we're going to have an outside drive curve and an inside drive curve. And the operation creates all of the cutter path in between the two when it morphs from one to the other. Here we see the outside drive curve and the inside drive curve. Morph across, on the other hand, is going to go in the other direction. It's going to go across the drive instead of along it. So in this case, it's almost doing a pie slice cut all around the round part. The important thing here that we're going to keep track of in the UI is, first of all, you have the option morph across, morph along, constant offset. So we're using morph across, but also the maximum step over and the minimum step over. The step over on the outside is going to be larger than the step over the inside, just because the radius of the part is larger on the outside than on the inside. And we're trying to keep the step over within that range. Notice with morph across, you do not need drive geometry. If I go to my drive geometry, you see that it's grayed out for display. There are no curves selected. There are no surfaces selected. Morph across creates the drive geometry automatically, and the user does not have to select anything. If it is not possible to keep the stepovers within the min and max range, we can split the operation and output. In this case, you see we're doing the morph across twice so that the stepovers can maintain the maximum step over and minimum step over on each individual split. That is done by split region width. You can do it by minimum step over, where it does an automatic calculation for the split, or you can do it by count, where you tell it to do a split. If we take a look at the other part, here's the morph across, and as it goes around the corners, you can see the outside of the corner has a larger step over than the inside of the corner. So again, you might choose to split that so that your step overs are closer and to the maximum step over and minimum step over range. Morph across has additional parameters when you split to geometry. You've got your split region offset, your first pass overhang from the start of the part, your last pass overhang, and your outer wall trim pass. This includes morph across for NX 2312 multi-axis additive. Thank you very much.
Often users need to visualize their additive buildup on each level to verify a complete build or look for potential voids. Now, users can display the IPW, or in-process workpiece, one level at a time, and cycle through levels with a mouse click or keyboard command. This improves the user experience when programming multi-axis additive parts.
Welcome to NX 2312 multi-axis additive. In this video, we're going to show a wonderful user experience enhancement that we're calling IPW per level. To demonstrate it, we're going to use a function in the CAM test new template that's called sparse buildup. In the function, you can see the IPW for any individual level on the part. So I'm going to turn on display IPW, and I'm going to cycle through the up and down arrow keys, and I'm going to see the IPW for just that level on the part. This makes it incredibly useful to verify the build on your part before you actually print it out. You can see each level one at a time, make sure that it's good before committing it to the machine. Additionally, you can just select any level on the operation and display IPW and see the IPW of that level, and not use the up and down arrow keys to cycle it. Note that the IPW it creates is not a permanent IPW, meaning it's for display purposes only. It is not an IPW that you can save and use somewhere else. You can also do IPW per level in the toolpath report. I turn on my display IPW and I can select any level or use the up and down arrow keys, and it will display the IPW on that level. This is NX 2312 multi-axis additive displaying IPW per level. Thank you very much.
In many instances, a hybrid additive subtractive machine is created by retrofitting a print head onto an existing 3-axis CNC machine. For this case, a full 5-axis version of multi-axis additive manufacturing is too much software, as the machine does not have the capability to rotate the tool axis while operating. For these cases, they can use the new fixed-axis additive manufacturing bundle. It provides a simpler interface without all of the tool axis options, a lower cost due to reduced functionality, and creates smaller NC files. Having a new low-cost bundle for less complicated parts, that is 3-axis only, can be a cost-effective way to get into additive manufacturing. It has less functionality because of reduced options and less expensive.
Welcome to NX 2312. In this video, we're going to show a new bundle, Fixed Axis Additive Manufacturing. If we look at the Fixed Axis Deposition template, we can see the operations in here are the same planar operations that you have in the multi-axis product, as well as some of the 3D freeform build-up options, but they're going to be limited in the tool axis. This is made for people who have machines with 3D print heads on 3-axis machines and not on robots and 5-axis machines. So if we look at this first operation, it's doing a smooth follow contour, but you're limited in the tool axis. If we look at the next operation, it's doing a planar zigzag buildup for this part. And again, the tool axis is going to be limited to just a fixed axis or normal to the slicing direction. Lastly, for that top portion, we're going to use 3D freeform buildup. And again, we're going to be limited to a fixed axis. None of the multi-axis for the tool vectors are available here because it's intended for a 3-axis machine. This new bundle makes it easier to get into multi-axis additive in a 3-axis version without the necessary functions of the 5-axis version if they're not needed. Thank you very much.
NXAM, Fixed Plane Reposition. Part augment the existing CAD-centric add and move part with additive-centric reposition. Part, translate part, rotate part. Align part, improve usability. Reposition parts using bounding box, supporting convergent bodies. Specify distances from build tray and/or build tray center. Reduce time to position and orient parts in the build tray Inline angled supports are now available in NX 2312. This means that when a situation calls for supports that are not vertical, the attachment to the face of the part can now be easily adjusted to match the angle of the attachment face. This can result in easier support removal and less material usage overall. When you are working with a build tray that contains a single part, you can add the build tray to another build tray. In the current situation, the build tray with a single part and its supports represents the development build tray. The build tray to which you add a single or multiple copies of the development build tray represents the production build tray. From now on, NX Additive Manufacturing uses part occurrences as associative references from the production build tray to the part data in the development build tray. If a development build tray has support structures, NX uses support occurrences in the production build tray, referencing the support data in the development build tray. The initial build preparation data is not duplicated in the production build tray, which improves performance significantly. Any change in the development tray will be automatically propagated to the production build tray using the synchronize command. We now go through the new part manufacturing data management enhancements. Active Workspace supports multiple home screens, so-called workspaces. We are offering a specific workspace for the manufacturing users. From here you have direct access to the commands and functions that determine your daily tasks. Now this workspace includes the Recent and Discussion areas. Under Recent, you can see all the objects you are currently working on. This allows quick access to the important objects that are currently in progress. Discussions provides an overview of parts you are collaborating on with your colleagues. From here, you can share comments and suggested changes across your organization. Multi-tools are tool assemblies that support multiple functions. For example, the same tool can be used to perform different turning operations. Multi-function tools typically include multiple cutting inserts. The user can now use the Teamcenter web user interface to define multi-tools in Active Workspace. This allows the user to easily prepare these tools to be used in the CAM environment.
First, the user creates, as usual, a tool assembly by adding all required components. At this point, the tool is only classified one time. To make this tool a multifunction tool, another classification needs to be added by Add Multitool Cutter. Now the tool is classified 2 times. The user can easily change the classification for each cutter. For example, one cutter supports grooving operations and will be classified accordingly. Looking at the classification information for each cutter, a unique cutter ID is assigned automatically. The cutter name and the 2 rotation angles, index notch and turret rotation, can be adjusted for each cutter. For the next step, the user assigns the correct insert to each cutter by setting a propagation start point. Here he selects the related cutter classification, for example, OD turning for the C-shape insert. This procedure will be repeated for each insert cutter combination to ensure that the correct attribute values from each insert will be available for the related cutter on the assembly level. The multi-tool is now prepared in the resource library and can be retrieved in NX CAM.
The download counter can be used for IE prototype parts or for uploaded NC programs, who can then be used for some time until someone checks it. In Teamcenter, we have at the NC program dataset level the ability to set a new object for revision limit, which means how often the NC program can be downloaded before it will be blocked for download. NX CAM on-machine probing offers some exciting new capabilities. NX on-machine probing is designed to efficiently map and customize specific customer requirements. An important focus was to provide operations dialogues as intuitive and intelligent as possible. This means that all parameter possibilities and available cycles are described with a tooltip and an image. The dialogues can be extended individually in all available languages provided by NX and the machine control for which the cycles were created. For modeling, state-of-the-art development languages such as Python and JSON are used. Extensions for the UI don't have to be laboriously edited in the source code. Editors are available which make it simple if necessary. NX on-machine probing, post-processor, and simulation add-ons are available for free via Siemens NX CAM Post Hub. The toolpath created for each operation will convert it into a probing cycle and thereby into a macro call via the post-processor. To assist with this, a free template layer is provided that you can easily integrate using the post configurator in the layer manager. If you use a different technology for your post processors, you can use it as a template. There is also a template for your CSE machine simulation to simulate the cycles, which can also be easily integrated into your simulation. The implementation of the extension in the post processors and the machine simulation can be done by your service provider if the user has limited experience in doing so. The add-ons are only meant as references. The responsibility for an error-free function is the user's. NX CMM Inspection Programming includes some exciting new capabilities. Axis symmetrical parts are always challenging to inspect with a non-rotary table machine. In order to efficiently inspect groove planes and cylinders, circles with star probes, a new path generation option is available. The collision-free inspection path is automatically generated, dramatically reducing inspection programming time, standardizing and improving path quality.
I would like to show this nice new functionality in NX Metrology CMM Inspection Programming, which is the groove path generation. Axis symmetric parts can be quite challenging with inner and outer cylindrical features and groove planes. The new functionality contains efficient inspection pass generation for inner, outer cylinders and planes. In order to create the pass, I create a new inspection pass. The new inspection pass will bring me up the inspection pass sub-operation. The default method is the point set, what I will change to scan arc. I will take a full circumference and I change the start tip mode to multi-tip. The multi-tip generates the inspection pass section by section where the probe can achieve the highest possible scan angle with the given conditions, which means that we can, for example, reduce the safety distance and then the transition moves get shorter and larger section of the part can be inspected. The same kind of inspection pass exists for outer cylinders as well. I use the same method. I create a new inspection pass sub-operation, and in the inspection pass, the best I can do is to select the scan arc and the multi-tip. I use the multi-tip, and again I reduce the safety distance to 2 millimeters, and in this case the inspection pass is being generated and the highest possible angle is measured with the specific start tip of the probe. The inspection plane can be generated in a very similar manner. I use scan arc. Angular limit is full circumference, 2 millimeters approach and retract. I will measure it from 50 to 100% that I don't touch the tooltip with the cylinder. And this is a multi-tip outer pass. And in case I apply it, then the correct inspection pass is being generated and possible to simulate.
Scan operations were handled as one large multi-section sub-operation. We improved the handling of the scan operations to be able to edit each section, adapting to the part geometry.
In CMM Inspection Programming, the inspection arcs, when we create a scan arc, the entire operation is generated with one sub-operation, which in many cases it's not very helpful, or it can be helpful when you can really edit the inspection pass in each little section. In order to do that, we have created a new functionality, which is the split scan up sub-operation. And in case I split the scan sub-operation, then each and every section of the big sub-operation of the scan arc is splitted into several smaller operations what can be edited one by one. And in this case, there is a special geometry inside one scan what needs a manual intervention. It is possible to do.
Next, we will go through the new enhancements in NX Assembly Line Planner. Using the new tool validation feature, you can select the optimal joining tool for an operation based on the tools, the products, and the fixture's geometry. This will help the planning engineer provide the simulation engineer with data that is already coherent, therefore reducing the need for changes during the simulation and reducing the amount of required change management workflows. This enhancement to the definition of the target takt time in Assembly Line Planner allows the planning engineer to define a station's target takt time that can be different from the line's target takt time. This could, for example, be used for stations which are duplicated in the line due to process taking longer. Instead of having a target takt time of 60 seconds as defined for the line, each of these two stations will have a target takt time of 1/20, as the flow of material in the line will alternate between them, allowing the real takt time of the line to still be valid. Now we will take a look at the new enhancements done in NX Line Designer. In NX 22312, Line Designer offers improved support for minimal load in both native and managed modes. Users can use the minimal load option to load and display plant structures using lightweight representations to improve load performance. Note that to avail the improved performance, the component must be saved in NX 2312. Native mode offers complete support for minimal load, including parts with connectors and kinematics, whereas in managed mode, parts with kinematics and the immediate parent node, which contains resources that are interconnected using connectors, are loaded partially. Note that you can see the loading status of components in the load state column of the Plant Navigator. The 2D Shadow Outline command is enhanced to improve the outline creation process for the users. Users can now generate outlines on an entire assembly or even a set of scoped selected content. Along with the options to generate simple and detailed outlines, more advanced options have been added, like being able to add the outlines on a plane of choice, being able to change the color of the outline, assigning layers, etc. The Define Tool command is enhanced to provide the users with the option to define tool tips. Once the tips are defined, this information can be reused in applications like Assembly Line Planner and Fixture Planner. In Assembly Line Planner, for example, in the Validate Tool command, in Station Detailing mode, these tips will be ignored while performing a collision check. A user can now add the Units column in Plant Navigator that will indicate the units of the components in the plant structure. We have come to the end of our What's New webinar and would like to thank you for attending. If you would like more information or further support on your manufacturing activities, do not hesitate to contact us. Subscribe to our channel for future videos and visit our website for more information. Until next time.